Hey guys, once again this is Teacher Nicoy and today we will be discussing about the basic calculus week 6 day 3. And today our topic is, our objective is to be able to solve the derivative of a composite function using chain rule. Okay, so what is composite function? So let's review some general mathematics. So we have here f of x is equals to, let's zoom in a little bit. Okay, so equals to x squared plus 2, and then g of x is equals to, let's say 2x. Okay, so if we say composite, so that's composite. You will insert g of x inside of all the x's of uh, f of x. Okay, g of x and f of x. Okay, so I will change the example into 2x like that. Okay, so I will change all the uh, f of x, all the x's of f of x into g of x. Okay, so just like here, so square plus 2. Okay, so that's the x's, the open blanks, the blanks here. That's are the x of f of x, and then I will change it to g of x. So 2x and 2x over here. So the composite is 2x squared is 4x squared plus, is it correct? Okay, 4x. So that is the composite of the composite of f of x, composite of g of x. Okay, so you remember a little bit of that already. So let's select this one and wait, select this one and try that. Oh no, not that one. Okay, all right, then let's go back here to the concept notes. Okay, so composite. Okay, so derivative of composite is you insert f of x to g of x, and then you what's this derivative of. Okay, so it is difficult to understand what is this, simply because it is really um, brain, what do you call that? Brain cracking. Okay, so let's try this example over here. So you will better know what is chain rule and this composite function. So it's just like the same, no? Okay, so we have here, let's put it here, f of x, because mostly here they do the shortcuts already, right? They do shortcuts, so let's not shortcut it. Let's do the long cut. So you will have better understanding of the topic. Minus 2x plus 4. Okay, that's our function here. Where? No, wait. We have still square over there. Okay. So we need to find or solve for. So the meaning of this 2 apostrophe, we know that this is this is first derivative, right? If we have 2 right there, it is to the second derivative, so we will derive this one twice. Okay, so first, let's not jump into getting the second derivative already. Let's just get it step by step. Okay, so let's have first the first derivative. Okay, so first derivative. Okay, wait. I like it here below because I have something to write there. Okay, so first we will need to have, we know this is a u to the power of n, right? Correct? So if we derive that, it will be n times u, and then to the power of n minus 1. So you remember that example, if you have 2x squared, so if we derive that, we will first separate the constant, then we will bring it down, and then we minus it. We subtract 1. So that is how to derive that, right? This is the function. That is the shortcut of it. Okay. So if we have that, because of this one, okay. So let's take a bigger picture first. So we have n. What is our n? It is this one. This is our n. And what is our u? So this is our so the u is this one, right? This is our u. So let's first put u is equals to 3x squared. Okay, we forgot this. We have du. Okay, always remember, after deriving it, you have du over here. Okay, 3x minus 2x plus 4. And then when we derive it, then it will become 3 times 2x minus 2, because this will become 0. Okay, then du is equals to 6x minus 2. Okay, so we have here u and du. So let's replace that because it takes here. Okay, so we'll just make it this one, 6x minus 2. Okay, and then what we will have here is we will substitute our values here. So we have here 2 times u. Our u is 3x squared minus 2x plus 4 times du, which is 6x minus 2. And then, okay, that is our first derivative already. Okay, you have here the first derivative. You may to get the second derivative, there are lots of techniques. Okay, you may first you multiply this using that method. you may use that method there, right? Okay, and another technique here is to use a what we call the multiplication method or rule, which we make this as u. U, and this one is v. So you remember in our past videos, we have this, as we all know, that derivative of two functions multiplied to each other is equals to u dv plus v du. So we have our u. Okay, I'll make it red. We have our u is equals to 3x squared minus 2x plus 4, and we all know that its du is 6x minus 2. And then we have our v, which is 6x minus 2, and our dv is this will be 0 and this will be 6. Okay, so we will just put here the second derivative of the function is equals to u. What is our u? 3x squared minus 2x. We put it red, so it will match the color. 3x squared minus 2x plus 4. This is it. And then times the v, which is, oh, I forgot, this should be blue. So this is dv. What is our dv? We have here dv, right? dv is equals to 6, so this will become 6. Okay, wait, what happened? So this is 6. That is 6. Okay, so this is dv, and then we plus, what is our v? Our v here is equals to 6x minus 2. So we have here 6x minus 2, and then multiplied by our du, which is 6x minus 2. Alright, So that is here. We have this is the one in the above du. Okay. So here we will multiply this. Okay. So oh wait, we forgot one number. What is it? This one. Okay. So we multiply it all by 2. Okay, no problem with that because it is a constant. It can it is not part of the derivation, but it is still part of the function or the equation. Okay, so let's have the okay, no more deriving to be performed, just simply multiplying it. Okay, so 3x squared, we will use this method. So 1 and 2 and 3. Okay, so 6 times 3, 18x squared, correct? We have here our calculator. 3 times 6 is 18 minus 12x plus 24. Then we have here plus. Then we will use this method over here. Okay, then plus 6x times 6x. 6 times 6 is 36x squared. Then minus 12x. Then minus 12x again and plus 4. Alright. And then we have, oh, don't forget to multiply by 2. Okay. So let's underline this. Okay. So we can have it very clear. All right. Okay. So 18x cubed plus 36. I mean x squared. So 18 plus 36 is 54. Okay. Don't forget to multiply it. 54x squared. And then we have here 12x, so 3 12x negative 12x minus 12x minus 12. Wait. Negative 12 minus 12 is negative 36x plus, okay, 28 square. And then we will, wait, let's check it out. Okay. And then what we have here is we will multiply it by 2. So 54 times 2 is 108 x squared minus 36 times 2 is 72x plus 28 times 2 is 56. So this is the second derivative of the function. Okay, so that's supposed to be the chain rule. So let's check if we have the same answer. Okay, so 108x squared minus 72x plus 56. Alright, we have the same answer with this. We did not use his technique here, or the author's technique, that they multiply it. If we multiply it, we get this, and it is more easier to derive this because we will not be using this UDV plus VDU, right? But the advantage is we did not have to multiply this one because this is like, oh, it is too many to multiply. Right. So that is the example number 1. So how many minutes would you get? 14 minutes for just one example. So I think this video will be very long, or maybe you just have to check this by your own. Try to solve it by your own because it is much better if you solve it by your own. Okay, so I find something that is kinda useless, or I think it is just a mistake of the author. I don't know, but he always forgot to put du, right? right here, cosine du. I mean, there's no du here because that is the function. So if we derive a function like here, uh, derivative of sine u, it is always, we will put here cosine u du. It is always mandatory to put it, but here, okay, maybe because they put it in dy over du, then they transfer du over here. So for me, it's much better to put always du here. Okay, so never forget to put du because du will save your life. Because when you forgot this du, like we forgot this constant number 2 here, that will trigger many mistakes in your solution. Okay, so let's try to solve this example number 2. Okay, so in this example number 2, I have here a cheat. Cheat. Okay, so this is just a something that you can have if you have not yet memorized this. But you need to memorize this also, the derivatives of trigonometric functions. So if you have not memorized it, it's okay to look at this one. It's very okay to look at this one. Okay, so here we have a function of y equals to sine 2x. Okay, sorry for the kid who is screaming in the background. Okay, so we all know that it is like deriving a if we derive that, we have here mean dy du, and then we have here sine u. Okay, it's not anymore sine u, but it's already what's the derivative of sine? It is here cosine x, so I will not use that. So I will just say let u is equals to 2x, and then we have let u is equals to 2x and du is equals to 2 because we derive it. Okay, and then we have here the derivative of y is equals to wait, where y is equals to sine u. Alright, and then if we derive it, it will be equals to, we have here sine u is equals to cosine u. So cosine u du, and then we put it cosine, what is our u? 2x multiplied by 2, and then our answer will be 2 cosine 2x. Okay, so that is how to derive a supposedly a trigonometric function. I don't know if it was using chain rule, but that's supposedly how to derive it. Okay. You always put du after it, and also here they have no du but they have dx here, so it just transfer here, it is dx also, because we all know that dx is equals to 1, right? What is the derivative of x? It is 1. If what is the derivative? The derivative of x is 1. The derivative of x squared is 2x. Okay. All right. Okay, so we have here another example, number 3, which is y is square root of x cubed minus 7. Okay, so just like here, we can transform that square root into a exponential function, that's over 1/2. Okay, so if we have a cube root, it is also 1 over 3. Okay. Okay, just like that. Okay, it is 1 over, it is a fraction, fraction of an exponent, exponential fraction, rational exponent. Okay, so here we have here, you already know the form of that. It is un. So what is, what is your u is x cubed minus 7, and your du is 3x squared. Okay, so what you're gonna do is derive this. If we derive that un, it will n minus 1 du. So what will happen here is we will be substituting it here. Our n is 1 half. So 1 half. Our u is our u. What is our u? X cubed minus 7. 1 half minus 1, it is negative 1 half. What is our du? It is 3x squared. Alright, so we have here 3x squared over 2 square root of x cubed minus 7. Okay, how did it get on down below? So first we have we over it 2, and then we have here x cubed minus 7 to the power of negative 1 half. As we all know, if we have negative here, to make it positive, we bring it down. Okay, so what will happen is 3x squared over 2 times x cubed minus 7 to the power of 1 half. So it's already positive. Okay, and then what will happen is you just take the root form. So x cubed minus 7. That's it. Okay, let's check if we have a correct answer. Okay, 3x squared, 2x, 3 minus 7. Is it the same? Is it the same right here? Whoa. Okay, the same. Okay, so I don't need to explain this ln x 7 to the power of 7, so it's just the same. Okay, first, let's explain this one. You have here y is equals to ln x 7, right? Okay, so first you have the u to the power of n. That is the form, and then you derive it. It will be n minus 1 du. Then so we have here u is equals to ln x, and our du is equals to, okay, our du is, we have here, you see this one, ln x is 1 over x. So we have here, it is also called as, if we derive ln x, ln u, then it is equals to 1 over u du. Okay, so we have here ln x is also equals to 1 over x. dx, derivative of x is 1, so no need to put it there. Okay, so we have here, we substitute it, is what will happen is n, what is our n? Our n is 7, so 7 times, what is our u? Our u is ln x, so no need to put it, ln x. Okay, we need to put it. Then x minus, 7 minus 1, it is 6. Then du is times 1 over x. So we have here equals to 7 times ln x to the power of 6 over x. Okay, so we have, what happened to his answer? His x is missing. His to the power of 6 is missing. Look at that. So let's correct this one. So supposedly it should have two, I mean two, not two, six. And also this one is 6. Okay, so never ever forget any exponent, constant in there. No? So that's it. Okay, so let's have an example that is nearer to this if you want. Or okay, I will give example that is the very difficult of the most difficult one. How about this one? I think okay, so I will have an example nearer to this. Okay, I'm having turns with this 2 over here. I will have this one for sure. How about this? Will I give an example to this? Or this one? So this one, okay, this one is so easy because you only have un, that is the form of un, and this one is sine u. But you will derive it twice, okay? So I will not give example of this because I have already explained something like this, okay? This is not in the example, right? Am I correct? Let's check it out if this is in the example. 1 over, okay, so it is not in the example. Okay, so I'll have an example of number 3. About number 4. Number 4. Okay, so number 4. Oh, wait. Okay, so number 4. Okay, I'll also have an example like number 4 and also have an example like number 5. Okay, so 3 more examples. So we have 26 minutes already passed. So we have 3 examples here. So I will have to pause it to make it to drink water. Okay. Okay, so we'll be using this example right here. It is just like just like that one. Okay, so first we will transfer it to the top. So what will happen is x cubed plus 2 to the negative 4, and then we will use the un, which will is equals to nu n minus 1 du, which we have here are u is equals to, u is equals to x cubed plus 2, and our du is equals to 3x squared. Okay, so we have it there already. So our answer, it's so easy, right? Answer is negative 4 x cubed plus 2 to the power of negative 5, because negative 4 minus 1 is negative 5. And then what happens? We have du, which is 3x squared. And then we will have it 4, negative 4 times 3 is negative 12x squared. And we transfer it below, so it will become positive, and we use the root form, which is like that, and 5, right? So it's so easy to have that. No need to make example. I was wrong. Okay, so how about number 4? Because of this x right here, it will make it difficult to because you will be using udv plus vdu, right? So let me erase this first. Okay, so we have here this example right here. Okay, so what we're gonna do is we will have it labeled as this one as u and this one as v. So we'll be having the u dv plus v du. Okay, so what is our u? U is x squared. Our du is 2x. Okay. How about our v? Wait. Let's make it okay, let's not make it colorful. How about our v? Our v is 4 minus x cube to the power 1/2. This one is more is trickier because you will also need to use the in here you will use the u to the power of n, and if we derive it, it will be n n u n minus 1 du. Okay, so we have here 1/2, and then our u is 4x. This will be dv. Okay, 4x. No. dv 4 minus x cube negative 1/2. Okay, so now it's difficult, right? Times du is derivative. Okay, so we have to derive that first. 4x cube. Okay, so our dv here is 1 over 2. So we have that 4 minus x cube. Okay, so that is square root over there, and then the derivative of this is, so we have here derivative of this is negative 3x squared. Okay, so you know that already, right? Okay, now we simplify it. dv is equals to negative 3x squared over 2 square root of 4 minus x cubed. Okay, now it's a lot difficult. Okay, so now we will have to use this one. So our u is x squared. Our dv, so we have that one. Our dv is negative 3x squared over 2 times 4 minus x cubed, and our v is square root of 4 minus x cubed times our du, which is 2x. Okay, so now we have here x squared and x squared. Is that correct? Okay, x squared. It is negative 3x to the power of 4 over 2, and then square root of 4 minus x cubed. Alright, plus 2x times 4 minus x cubed. Okay, so this could be our final answer already. Or we can also still have it simplified. Okay, so we have here, we over it to 2 over 4 minus x cubed, and then here is negative 3x4, then we divide it to 1, then we multiply it to the above, so plus 2x 4 minus x cubed multiplied by 2 and square root of 4 minus x cubed. Okay, so here we have here negative 3x to the power of 4 plus 4x, so because we multiply the constant and the variable here outside first, and then it is the same, right? So it is considered square root, or it is 4x cubed square, or this is the fun part of that, or it is considered as 4 minus x cubed over 2 over 4 minus x cubed. Okay, so we still have a lot of going on here because we can multiply this one. So 3x4 plus 4, we multiply it, 16x minus 4x cubed. Okay, no, that is not cube, rather 4x to the power of 4. Okay, Now we have, oh no, don't never forget this one. Okay, 4 minus x cubed. All right, and then negative 7x4 plus 16x over 2 square root of 4 minus x cubed. Alright, so that will be our final answer. Okay, so as you can see in the steppings, steppings, just like you're dancing, right? So you need steppings and you need to incorporate, or you need to do certain steppings inside a stepping. So it's a bit complicated. So you see how long our computation or our solution is for just a tiny question. All right. So I will also give an example just like this number 5. Oh wait, we can also still simplify this one. We get the x. We extract the x, and then we have left is 16 minus 7x to the power of 3 over 2 square root of 4 minus x cubed. Okay, so that's still the same answer. Alright, so that's it. Okay, so okay. So I'll make an example again for this number 5. Okay, here in the example, just like exercise number 5, instead of using cotangent to the power of 3, we will use sec to the power of 3, right? Okay, here. Okay, here. Let's see here. Okay, when using cotangent, you will only have to have negative cosecant square x. But in second, you will have secant tan x. Okay, so good luck. So this is like good luck to me, right? Okay, so this is also just like saying sec e to the power of t, and then you cube it. Okay, so you will have the u to the power of n. If we derive it, we'll have n u, and then n minus 1 du. Alright, so we have here what 3 times sec e to t times square du. So derivative of sec. So we're not done yet. We're just in the first what you call that, first term. So we have to derive this still. So it is already here. It is don't forget this one, sec. If I'll be the teacher, I will not give like this in the exam because it's too long, unless you are already in the engineering department. Because this is too complicated already, but we still need to solve this one. Okay, so we have here okay, so here we have our u is this one. Okay, the derivative of this is just like eu. Sorry, not eu, but sec u, which is equals to if we derive that, it is equals to sec u tan u du. Okay, so never forget that du over there. So we have here, we will just, the derivative of that is sec e t times, okay, we put that like that, sec et times tan e to t. Our du is derivative of e to the power of 2t. Alright, okay, so that's our u right there. It's very long, right? And then we have here, we will copy this one. Sec e to t square sec e to the power of t times tan e to t. Then what's the derivative of this? So we have here e to the power of u. And then we all know that if we derive that, it is eu du. So okay, so we have here eu, which is e to t, then derivative of 2t. Okay, so we have here 3. We will just copy it here, 2t square sec e to t times tan e to t, and then e to t. What is the derivative of t? It is 2. Okay, so we have here 6. Okay, so this one, as you can see, this one and this one is just the same, so I can put it as sec e to t cube. Then back to my tan e to t and e to t to t. Okay, and then we have here 6 e to t e to t times sec e wait, you can have it sec cube e to t and tan e to t. This will be my final answer, but I know there are some techniques that you can still, what you call that, simplify this one. Okay, so maybe okay, for me this is already good, but for others maybe this is still derivative. I mean, can be simplified. So that's it for day 3. So it is very long, right? It is too long. Hope you can answer it. This one with this guide here. So thank you for watching and hope you learned something today. Thank you.